Welcome back to Java Internals Crashcasts. I'm your host Sheila, and today we're continuing our journey through the synchronization utilities season. We're in the synchronizers chapter, and after discussing semaphores in our last episode, we're moving on to CountDownLatch. Victor, are you ready to count down with us?
Absolutely, Sheila. I'm excited to dive into CountDownLatch. It's a powerful tool in the Java concurrency toolkit that many developers find incredibly useful.
Before we get started, let's remind our listeners that to fully grasp today's topic, they should be familiar with basic Java concurrency concepts and thread synchronization. Now, let's kick things off with a quiz question for our listeners. Here it is. In a distributed system, you have 5 services that need to initialize before your main application can start. Which Java utility would be most appropriate to coordinate this startup process?
Oh, that's an intriguing question, Sheila. It really makes you think about coordinating multiple processes. Without giving away the answer, I'd say listeners should consider what kind of tool would allow separate processes to signal when they're ready, while a single point waits for all of them. It's a great real-world scenario to ponder.
Exactly, Victor. Now, let's start with the basics. Can you explain what a CountDownLatch is and why it was created?
Certainly. A CountDownLatch is like a gate that doesn't open until certain conditions are met. It was created to help coordinate actions between multiple threads. Imagine a group of friends agreeing to meet before entering a party together. The latch is like the meeting point, and it won't let anyone proceed until everyone has arrived.
That's a great analogy. So, how exactly does it work? What are the main actions we need to know?
There are 2 primary actions: waiting and counting down. Threads that need to wait for others call a method to wait. This method keeps them on hold until a certain count reaches 0. Other threads call a countdown method when they complete their task, which reduces the count. When the count hits 0, all waiting threads are released.
I see. But what happens if a thread tries to wait after the count has already reached 0?
Great question. If a thread tries to wait after the count is already 0, it won't have to wait at all. It's like arriving at the meeting point after everyone else is already there. You can proceed immediately.
Interesting. Now, you mentioned it was introduced in Java 5. Has it changed much since then?
The core functionality has stayed largely the same. However, Java 8 brought some general improvements that indirectly benefit CountDownLatch, like better documentation and some behind-the-scenes optimizations.
I see. Now let's dive a bit deeper. Can you explain how CountDownLatch manages the count and the waiting threads under the hood?
Sure, think of it like a really efficient waiting room. The count is like a number on a display. When threads come to wait, they take a seat if the number is above 0. Each countdown call reduces the number, and when it reaches 0, everyone in the waiting room is let out at once.
That sounds quite efficient. Are there any limitations or potential pitfalls we should be aware of?
One important thing to note is that CountDownLatch is a one-time use tool. Once the count reaches 0, you can't reset it. It's like a launch sequence. Once the rocket has taken off, you can't use the same countdown again. Also, if a waiting thread gets interrupted, it might stop waiting earlier than expected, which could cause issues if you're not careful.
Those are crucial points, Victor. Now, can you provide a real-world example of where CountDownLatch might be particularly useful?
Absolutely. Let's go back to our distributed system example. Imagine you're starting up a big online store. You have separate services for inventory, user accounts, payment processing, and so on. You want to make sure all these services are up and running before you start accepting customer orders. CountDownLatch is perfect for this. Each service would signal when it's ready, and your main system would wait until all services have signaled before opening for business.
That's a great example, and it actually relates to our quiz question. Speaking of which, would you like to reveal the answer now?
Sure. The most appropriate tool for coordinating the startup of 5 services in a distributed system would indeed be CountDownLatch. You'd set it up to wait for 5 signals, have each service send a signal when it's ready, and have the main application wait until all 5 signals have been received.
Excellent. Now, as we wrap up, could you summarize the key points about CountDownLatch for our listeners?
Certainly. Here are the main takeaways. 1. CountDownLatch is like a gate that coordinates multiple threads. 2. It starts with a count and has two main actions: waiting and counting down. 3. It's a one-time use tool. Once the count reaches 0, you can't reset it. 4. It's great for scenarios like coordinating startup in distributed systems. 5. Under the hood, it uses an efficient system to manage waiting threads. Remember, count down to lift off. It counts down, then releases threads.
Thank you, Victor. That's a great summary. In our next episode, we'll be discussing another fascinating synchronizer called cyclic barrier. Don't forget to subscribe to Java Internal's Crashcasts and leave us a rating if you're enjoying the series. Until next time, keep on coding.